Okay, so we are back again multiplying polynomials, and we're going to start off with just multiplying binomials first because those are probably the most common problems that we run into. And the first method we're going to use is called the FOIL method, and FOIL stands for multiply your first terms, multiply your outer terms, multiply your inner terms, and multiply your last terms. And it's just a mnemonic to help us remember how to use the distributive property. And so when we're looking at our problem and we're saying, okay, let's go ahead and multiply this out, and I want to use FOIL, I multiply the first term. So my first term in this binomial times the first term in this binomial. And then we move to O, which is our outer terms, so the outside and the outside. And then we move to I, which is our inside terms, so inside and inside. And then we move to L, which is last and last. And again, it's just a formal way of telling us that we're going to distribute. And then once you've multiplied that out, then we're adding each term. So here is the first, the outer, the inner, and the last, all added up. And the only ones we can combine are these two. So we go ahead and combine them, and that's how we get our final answer. So we're going to go ahead and work this out. We're going to go ahead and FOIL. And I like to think of it as I'm going to distribute my x to the x. So I get x squared. And then I distribute it to the -2. So then I get -2x. And there's my first and outer right there. And then I'm going to go ahead and work to my second term in that binomial, the 4. And I distribute it to this x. There's my inside terms. And then I distribute it to the -2. There's my outside. And it just gives us a real organized way of looking at it. And instead of writing it like this up here, I like to write it like this. So that way I know this is my x times the binomial, this is my 4 times the binomial, and then it lines up those like terms for us. So we get a final answer of x squared, and then a -2x plus 4x gives us +2x and -8. So we're going to go ahead and try another one. So we're going to go ahead and multiply x times x times -7, and then I'm going to multiply -6 times x, and then -6 times -7. We combine our like terms, and there's our final answer. So those are really nice, simple binomials because our x's were just x's. There's no number in front. So now we're going to mix it up a little. We're going to have some numbers in front here. So now I'm going to go ahead, and I don't have a lot of room above. So 2x times 3x, so 6x squared. 2x times 4 is 8x. Switch to another color here. So -1 times 3x. -3x, and then -1 times 4, -4. And again, we combine those like terms. So 6x squared plus 5x minus 4. Okay, so next one, same idea. Multiply 8x times x, so 8x squared. Then 8x times -4, so -32x. And now we're going to go ahead and distribute that -3, so -3 times x, -3x, and then -3 times -4, which is +12. We combine our like terms, so we get 8x squared minus 35x plus 12. And that's the FOIL method. We also have the box method. It's also known as the area method. It's really popular now in Common Core because it relates our multiplying polynomials to actual problems dealing with area, which is probably where you could use this the easiest in real life. Well, it really depends on what you're going to do with it. But the idea here with the area or box method is you take the first polynomial and you write it on the side. So my first polynomial would be 3x plus 5, and I write it right here. And then if my second polynomial is 2x minus 7, I write it on the top. And so it gives us an avenue of multiplying everything out and making sure we're multiplying the right things together. And so here, that means to get this answer, I'm going to multiply this 3x by the 2x. So 3x times 2x gives us 6x squared. It's the exact same thing we were doing with the foiling and the distribution, but it lines it up and organizes it really nicely for those people who tend to get distracted and didn't realize what they were multiplying and all that sort of stuff. So it just kind of focuses and organizes things. So now for here, I'm going to multiply 3x times negative 7, so negative 21x. And then I multiply 5 times 2x, which is 10x. And then I multiply 5 times negative 7, which is negative 35. And then our like terms are on the diagonal. So our final answer would be 6x squared. And then I have a 10x minus 21x, which is negative 11x. And then the minus 35. So we're going to go ahead and try and work out a couple like that so you can see how that works. So I have an x plus 4, so I'm going to draw a box a little bit smaller because I don't have a lot of room. So x and then plus 4. And then my next one is x plus 8. So on the top, x plus 8. And then we just multiply the sides. So x times x, x squared. X times 8, positive 8x. And then I'll move down one. So 4 times x, positive 4x. And then 4 times 8 is 32. Again, on that diagonal is going to be those like terms that we're going to combine. In fact, it's got this little plus here conveniently for us to show us that's what we're combining. So our answer would look like x squared. 4x plus 8x gives us 12x. And then plus 32. So I got a little bit more room over here. So I'm going to go ahead and draw a box. So it's a little bit easier to see. And we're going to go ahead and take the first polynomial, 2x minus 1, and we're going to write it on this side. And then we're going to take the second polynomial, x plus 6, and we're going to write it on the top. And then we're going to multiply the sides. So 2x times x is 2x squared. 2x times 6 is 12x. And I'm going to move to another color. So negative 1 times x is negative 1x. Negative 1 times 6 is negative 6. And again, on the diagonal, we have those like terms. So we get 2x squared. Then combine the like terms, negative 1x plus 12x. Or we can look at it backwards. 12x minus 1x is 11x. And then minus 6. And that's our final answer. Now, when it comes to binomials, either way works out just fine. So I really don't care which method you use as long as you're just consistently doing it correctly. But as our polynomials get bigger, I personally like using the box method. So now I have a binomial times a trinomial. And again, it just helps organize things for my brain. And so I prefer to do it that way. And so again, you could use a distribution option, and that's totally okay. FOIL doesn't work if you have a trinomial because the idea of first, outside, inside, and last doesn't work if you don't have the right number of terms. So you could still just distribute. You could do x times this, x times that, and x times that, and then go negative 1 times this, negative 1. I mean, you could still distribute, but the FOIL mnemonic doesn't work anymore. Okay, so I'm going to take my first polynomial, x minus 1, and put it on the side. I'm going to take my next polynomial, x squared. Probably should use a different color up there. There we go, we can see that better. So x squared, and then my next term plus 3x, and my last term plus 4. And so now we can multiply our sides again. So x times x squared, x to the third, x times 3x plus 3x squared, x times 4, a positive 4x. And then I'll move down. negative 1 times x squared, negative 1x squared, negative 1 times 3x, negative 3x, negative 1 times 4, negative 4. And what's nice here is we're still getting those like terms, like here's my x squareds, here's my x's. And it still allows us to combine those like terms. So my final answer will start off with our highest, x to the third, combine the x squared, so negative 1 plus 3 gives me 2x squared. And then 4 minus 3x is 1x, and then the minus 4. And so that's our final answer. So as our polynomials get bigger and bigger and bigger, you may want to use a box to help organize it. But again, all I care about is that you're consistently multiplying them correctly. Okay. And so here, again, just a lot of different problems using any method you want. So here we could go ahead and use FOIL. So 2x times 4x, 8x squared. 2x times 1 is 2x. And then 3x times 4, oops, forgot my x. So 3x times 4 plus 12x. 3 times 1 plus 3. Combine our like terms. Yeah. Okay, so my brain was jumping ahead on that problem, so I apologize if I sounded a little distracted. And that's because I was thinking about how do I talk about problem I? So this one I want you to put stars around because it's the one that most people have an issue with. They tend to think that if I have x minus 3 squared, that we're allowed to distribute the squared inside. And that's not true. That's a big no-no. That is not allowed in mathematics. And I could show you why with an example, but it's easier to just, before I confuse you too much, just go ahead and talk about what is the correct way of doing it. So if I have an x minus 3 squared, that's really saying that I'm multiplying x minus 3 2 times. So it's just saying I'm too lazy to write out x minus 3 twice. So I'm going to use that symbolic notation because that's what squared means, is I'm taking whatever is being squared and I'm multiplying it by itself twice. And so now what we're going to go ahead and do is just multiply the x minus 3 times x minus 3. And we can FOIL that out if we wanted to. So x times x is x squared. X times minus 3 is minus 3x. And then negative 3 times x is another negative 3x. Negative 3 times negative 3 is a positive 9. And so when we combine like terms, we get x squared minus 6x plus 9. And so as you can tell, if we were to go back and actually distribute that squared, we get x squared plus 9. Which means we missed out on half our problem because the minus 3 and the minus 3, which becomes a minus 6, is all missing because you tried to take a shortcut that really truly doesn't exist. So this, not cool. Do not do that, please. Okay, so our next problem, very similar, purposely set up that way. So I'm going to put little stars here. 3x plus 2 squared, really just 3x plus 2 times 3x plus 2. And I'm going to go ahead and use the box method for this. So I'll draw myself a box. I'm going to go ahead and take the first polynomial and write it on the side. So 3x plus 2. The second polynomial goes on the top. 3x plus 2. And then we multiply the sides. So 3x times 3x, 9x squared. 3x times 2, positive 6x. Then we'll move down, need another color here. 2 times 3x is a positive 6x. 2 times 2 is a positive 4. And so again, we can see on our diagonal, we've got those like terms. So 9x squared, 6x plus 6x becomes our 12x, and then plus 4. Helps if I write the x. There we go. Okay, that's bothering me now. We'll fix that x real quick. There we go. Yeah, everyone makes mistakes. Okay, and for our last one, I showed you already how you can do this using the box method. So I'm going to go back and use this using the distribution property. So those of you who like the distribution property know what it looks like. So I'm going to go ahead and take the 2x, I'm going to multiply that by everything over here. So 2x times negative 4x squared becomes negative 8x to the third. And then I'm going to go ahead and multiply here. So 2x times negative 10x becomes negative 20x squared. And then 2x times 3 becomes a positive 6x. So now I distributed the 2x, I'm good to go to move on to the next one. So now negative 5 I'm going to distribute. So negative 5 times negative 4x is positive 20x squared. So I'm going to line this up with my x squared. And then negative 5 times negative 10x becomes positive 50x. And then negative 5 times 3 becomes negative 15. And so it lines up nicely for us to combine our like terms. And so we get a final answer looking like negative 8x to the third. These cancel each other out. Plus 56x and minus 15. And you can leave your answer like that. If you wanted to put in a 0x squared, that's totally okay. Or if you hate having a huge gap, you can write it all together. Again, all I care about is that your answer is mathematically correct. Okay, so we'll do a little bit more practice on this, and then we'll talk about special patterns, and then we're done with the chapter.